So it is day 10 in geometry. We are in unit 2 looking at triangles, and it is Tuesday, October 21st. So yesterday, you guys learned about the interior angle sum, the exterior angle sum, and then we talked about mid-segment theorem. If anyone would like review on that after today's lesson, you're welcome to stay and we can run through it some more. But for today, we are going to move forward and talk about different types of triangles. So our little subtitle is going to say classifying triangles. And something that you may hear more in, say, a biology class is classifying things. You're doing a lot of classifying with types of animals, types of species. You classify by different things. We do that a lot in geometry as well because we're classifying shapes and we put them into groups based off of usually side lengths or angles. So the first section that we're going to be classifying by is by the angles. So a smaller title under here will say classifying by angles. Classifying by angles. And beside that, I'm going to put the angle symbol just to help us remember that's what that means. So whenever we are classifying triangles by angles, what's really nice is in the last unit, we learned about some angle types. We learned specifically about what's an angle that is less than 90 degrees. Anyone remember? Acute. Good. So my first subtitle will be acute. I'm going to write acute triangle. Draw a little triangle. And I'll highlight that. And give yourself space to put 3 different types. So what I actually may do here is give myself 3 little sections. So acute, and then I'll draw a line about 2 inches long-ish, maybe 2 1/4. And then what kind of angle is 90 degrees exactly? Right angle. So the next type of triangle will be a right triangle. So another little 2-inch divider. And finally, what type of angle is bigger than 90 degrees? Obtuse. Obtuse, that's the third type of triangle. Obtuse. Obtuse triangle. There you go. So, when we're looking at these 3 triangle types, we're going to give a short description of each type, and then we're going to draw a little picture to help us. So under acute, for a triangle to be considered an acute triangle, all 3 angles have to be less than 90. All 3. So we're going to write 3 angles less than 90. You can write all 3 angles. Every angle in the triangle must be less than 90. Next, our right triangle just has to have one angle that is exactly 90 degrees. So one angle exactly 90 degrees. And then finally, our obtuse triangle has one angle greater than 90 or bigger than 90 degrees. Degrees. Now, think about the angle measures in a triangle and what they add up to. Do you think there's such thing as a straight triangle? No. Why not? Anybody know? It would be a straight line. A straight line is 180 degrees.
It's closed off.
Right. There's not enough degrees in a triangle to give us 3 angles. A triangle has 3 sides, 3 angles. If one angle is 180 degrees, we've used up all our degrees. There's no way we can put other angles in there. So these are the only 3 types we can have, just these 3. So for our acute triangle, we can draw a picture where it looks kind of like your classic triangle. This one is not as difficult to draw. I like to just do a 1, 2, 3. These 3 angles are all less than 90 degrees. So I'm going to mark the 3 angles as being less than 90. These angles are less than 90. They're all acute. Next, we'll draw a right triangle. And whenever you're drawing a triangle with angles greater than 90, you always want to start with that biggest angle. So I am going to start with a line segment that goes straight up and down, as close to up and down as I can get. Make that about an inch or so long. Let's see, that's pretty close to straight up and down. Then I want to draw the other leg of the angle to create my 90-degree angle. Should look like a perfect corner, or as close as you can get it. Once you have those 2 line segments drawn, we just connect the other endpoints like this. What do we mark a 90-degree angle with? The square, that little box. So on your right triangle, make sure that you put a box or a little square where that 90-degree angle is. Anytime you see that, you automatically know that's a right triangle. Every time. Last but not least, we'll do our obtuse triangle. And what I like to do is I like to think about how with a 90-degree angle, I start straight up and down. Instead, I'm going to take my ruler and I'm just going to tilt it further, just a little further. And we're going to start by drawing some sort of obtuse angle. So I like to tilt it this way, draw a little line segment, and then we'll draw a line going straight across like this. That way I have an obtuse angle here. Once you've got that obtuse angle, we just connect the endpoints of those two line segments. And we have an obtuse triangle.
It's very simple to build. Just squish.
Yeah, it really does. These triangles are all just little slightly differently slanted versions of each other. So we'll take the obtuse angle and we'll highlight that just to make it stand out a little and to help us know that this is the angle that's bigger than 90, greater than 90. So we use 90 as our reference point. That's kind of what tells us, well, if it's smaller than that, it's acute, and if it's bigger, it's obtuse. 90 is our reference point here. I don't know where I put my cat. So I'm going to shift that up a little bit, and I am going to start the next little section here where we just classified by angles, but now we're going to classify by side length. I'll just draw a little line to separate the two. Side length. Now these next three sections that I'll have you do, these may be words you've never heard before. What do you have? Yes, we'll see. What I'm going to do first, though, is draw these dividers again down below, just so that I keep everything about the same. And does anyone still need to see the angles? Or can I move down? Okay, I'll move my paper down. So for classifying by side length, draw those even. Finish that one. I don't know how I made it worse here. Okay. Yeah, close enough. Okay, so for side length, we're going to start with our first title, equilateral. That is E Q U I L A T E R A. Equilateral triangle. That's a mouthful. Is this a brand new word for any of you? Or have we heard this before? Heard it before? Might be familiar. Maybe you've heard it in the past. Equilateral triangle. Next we have isosceles.
We got that one yesterday.
ISOSCELES. We have equilateral triangle, isosceles triangle, and last but not least, we have scalene. It's like learning a new language. Lots of fancy words. Equilateral, isosceles, and scalene. So, now that we have our three names written down, we're going to draw. Well, not draw yet. Let's get some definitions. First, does anybody know what an equilateral triangle is? Do we have any guesses?
Yes, the sides are equal.
All the sides are equal. Yes. An equilateral triangle has all three sides the same length. So that's what we will write. All three sides are the same length. All three. Next, we have isosceles. Does anybody know what an isosceles triangle is?
Got it.
Well, you know it, Kelsey?
Is that the exactly 90?
Not quite. This one has to do with the side lengths.
Oh, I see. Okay.
We may not know it. That's okay.
Yeah, I don't know.
So, an isosceles triangle has two sides that are the same length, just two. So, two sides. Same. And then finally, scalene. Does anybody know what a scalene triangle is?
Sides are equal.
None of the sides are equal, so all three sides are different lengths. Good. So all three sides are different. I like different since we're talking about the sides are different, not the same. What do you think?
Unsolvable. Like it's unsolvable.
There could be some unsolvable things. I'm actually taking you in a direction you may not guess. But you'll see. You'll see. Okay, so what we're gonna do after you've gotten all of those written down is we'll draw some pictures. And it's okay if your pictures are not perfect, but it would be helpful if your markings are correct. Gotta have the correct markings. So for an equilateral triangle, it's tricky to draw one because to draw by the side length, if your angle is off by just a little bit, all three sides won't be the same. So just do your best. But I'm gonna make my sides like 1.5 inches long, and I'm gonna try to make it look about like this triangle because these all have about the same angle, about the same length. So I am gonna start with approximately all the angles should be 60 degrees. That'll give you all three same sides. That's okay if it's not perfect, but I'm gonna put the line here. Let's see. What was that? 1.5 inches. Then I'll do another 1.5 inches. If I guessed right, then I should, oh, yes, okay, good. 1.5. It's okay if it's not perfect, but we have three sides that are the same length. Now, the way that we mark this, we kind of saw a little sneak peek of marking sides that are the same with the perpendicular bisector. If you remember, we said that line segment was exactly the same length on each side, And we showed that by putting little tick marks. So all three sides are the same. Every side gets the same number of tick marks, one for each. So this is how an equilateral triangle would be marked. Isosceles, I think, is the easiest to draw. Because long as you have two sides that are the same and you don't make them 60 degrees like this, then you should be okay. I'm going to do the same, about 1.5 inches for my first length. But this time you want to close the angle a little smaller. Or you could make it bigger. Make it the same length. Oops, I made that too big. Okay, what did I make that? It's like 3/4-ish. Okay, so these two line segments are about the same length, and then I'll just connect the endpoints. Close off my triangle. The way we would mark an isosceles triangle is we'll give the lengths that have the same, or we'll give the sides that have the same length 1 tick mark. But my third side cannot also have 1 tick mark because it's not equal. So this is when we move to 2 tick marks. That just means it's not the same. So we're going to get out. Mark 1 tick, mark 2 tick. Then last but not least, we have a scalene triangle. This one can be kind of tricky to draw. Just do your best. Just start with, I might start with a line right here, going up and down, and I'm going to make that about 1 inch. And then, if you really want to make a scalene triangle, you can always start with a right angle. As long as these two lengths are different, because that diagonal length this way will never be the same, and we're going to talk about that here. And then I'll make this next line 1.5 inches. And then my two connecting pieces will be almost 2 inches, maybe 1 3/4. So similar in length, but not the same. All three are different. And this time, all three sides get a different number of tick marks. So I might do 1, 2, 1, 2, 3. There you go. And there are our triangle types. So that is the first page of your notes. Title or labeled, this is week 1. And I will pause the recording and let everybody get that written down. All right, so keeping that in mind, let's go to page 2. And I will retitle my notes. This is page 2. And page 10, notes continue. some point, whenever we do take a quiz over triangles, I will say we will need to know triangle types. And it's not something that you can do a ton of practice with other than looking at pictures and saying, oh yeah, that's equilateral, that's isosceles, that's scalene. So what I would like for us to do, if you know you're going to have a hard time finding this page later, take a sticky note, bookmark this, and maybe write on the outside triangle types. That way you'll know exactly where it is when you need it. So I'm going to write right on the very end here. Triangle types. This will make it much easier to find later. So I'm just going to put that right here. Stick it on. And now, when I close my notebook, boom, it's right there. Don't even have to search for it. I just go, oh yeah, there it is. I love making that. It makes your life easier. So, moving on to page 2. We are now going to zoom in and look at right triangles specifically, because right triangles have some special rules that only apply to right triangles. So, I would love for us to title this page with right triangles. Right triangles specifically. Here is what I want you to do. We're going to draw another right triangle, but this time we're going to make it a little bigger. So I am going to make the first leg, the one that goes straight up and down, I'm going to make that 2 inches. Inside. And I'm going to label that 2 inches. For the other leg of the right triangle, we will make our side. Let's go with 3 inches. Then I'm going to measure and see where length ends up landing for this one. Now, we're in between measurements. I don't want to use fractions or decimals without knowing for certain. So what we're going to do for now is we're going to draw the third side length, but I'm not going to have you write a measurement yet. We're just going to draw the side length, and we're going to learn how to solve for it. Important, don't forget to draw that little box, little square that shows this is 90 degrees. And I want us to make another note on our picture. Notice we have that 90-degree angle. Across from the 90-degree angle, we have a side length. I'm going to draw a little arrow pointing to the side length. I'm going to kind of highlight that diagonal side here. This side has a special name with right triangles. And that special name starts with an H. Does anyone know it? I'm always curious to see if anyone already knows. Maybe not. It's a funky word. HY. Ring any bells?
Pop, pop, Hypotenuse.
Hypotenuse. Yes,
Okay.
it's called the hypotenuse. So, honestly, hypotenuse. That's how we kind of spell it. Hypotenuse. Hypotenuse. Funky word. The hypotenuse is always the longest side of a right triangle. Always. The longest side. Hypotenuse. And the other sides, we just call those the legs of the triangle. We could say leg. And then I'm going to give you a formula. Lots of really funky words today, so I'm sorry about that. But the next funky word is Pythagorean. Oh my lord. Pythagorean. Has anyone in this room heard of the Pythagorean theorem? Maybe, maybe not. The Pythagorean theorem sounds scary, but it's not too bad once you break it down. The Pythagorean theorem, which I'm going to write that name, Pythagorean. Pythagorean. Everybody say that. Repeat that after me. Pythagorean. Pythagorean. Good. Pythagorean. Pythagorean theorem is going to help us solve for the hypotenuse or for the legs. Now we know the legs in this case. We're going to use it to solve the hypotenuse. Theorem. Pythagorean theorem.
You're not wrong.
Yeah, it sounds like a villain. Pythagorean theorem. So the Pythagorean theorem is this. It's a squared plus b squared equals c squared. And that's it. So I'm going to just kind of box that into its own little section. So I remember that this is an important formula that we need. Pythagorean theorem. This is only used for right triangles. Only. I don't believe you can use this to solve for lengths with other triangles.
Somebody's trying.
I'm sure they have. Okay, so let's put this into some context. Let's use this. So in the Pythagorean theorem, a squared plus b squared, a and b are the legs. So if it helps you to label this, a and b, it doesn't matter which number you put where. As long as the two short sides are a or b, your answer will not change depending on what spot you put it in. So, legs. Or the two shorter sides. C is your hypotenuse. Below all of this, first example of using the Pythagorean theorem I will write some directions. I will just write. You don't have to write the directions. I'm just going to write it in case it helps. Say solve for the missing side, the hypotenuse. So we know two side lengths. I know one of my legs is 2 inches. I know one of my legs is 3 inches. I can write 2 for A or B. I can write 3 for A or B. As long as I use both numbers, it won't matter. So I'm going to write kind of a step by step. A squared plus B squared equals C squared. And now we're going to replace A with 2 and B with 3. 2 squared plus 3 squared equals C squared. Just plug in the lengths of the leg. And now, once you plug in your numbers, we need to simplify this side of the equation. I have 2 squared and I have 3 squared. Remind me, what does 2 squared mean?
2 times 2.
2 times 2, 2 times itself. What is 2
4.
times 2? Yes, it's 4. Write down my plus. And what does 3 squared mean?
3 times 3.
3 times 3. It's 3 times itself. So
It'd be
3
9.
times 3, which is
9.
9. And then I just bring everything down. Equals C squared. So what should I do now?
4 and C equals
Yeah, add 4 plus 9. So what is 4 plus 9?
13.
13. And I need to bring everything down still. 13 equals C squared. Have I solved for C? No. And we can look at our picture and tell that that doesn't make sense. C isn't 13 because this is 3 inches. This is 2 inches. Our hypotenuse shouldn't be 13. It should be close to 3 point something because it's just a little bigger than 3 inches. So what is the last step I haven't done yet?
Square.
My squared. I need to get rid of that. Do we remember what the opposite of squared is? Square root. Okay, so quick little mini lesson in case you don't recall how to find the square root. On your calculator, you'll need to use the second button, the blue button. And there will be a square root above the x squared key right here. Square root will pop up. And I will just type in my 13, which I should have done this first. We have to get C by itself, so we square root both sides. Enter. And look at that. That makes a lot more sense. 3.6055 and so on. Good. So that cancels the squared, and I can bring down 13. Square root of that is 3 point, I'll just say 3.6 equals C. Yay! We did it. We did it. Good, good, good. And so that's our missing side length. That's all there is to it. The only thing that could make this one step trickier is if we are not solving for C, if we're not solving for the hypotenuse. Because sometimes you'll be given the hypotenuse and you won't have one of the legs. So we'll have a little bit of rearranging to do. So this is an example of solving for the hypotenuse. I want to show you an example of solving for a leg. So right below that, I'm going to write another little title that says solve for the missing side, but in parentheses it will say leg. Solve for the missing side. C side leg. So for this next problem, I will tell you that maybe I can draw a little picture here. So I'm going to draw like a little tiny picture next to it just to give a little context. And my hypotenuse is, let's see, what did I put here? 48.5. And then one of my legs will be 26.2. And then I don't know this other leg. I don't know what it is. Now remember, the legs can be A or B. But what has to be C? The hypotenuse. So if I am plugging these numbers into A squared plus B squared equals C squared, I know that 48.5 is the hypotenuse, and so it has to be C. What I might recommend is that your missing side, if it's not C, make that A, because I like to have my variable at the beginning. You could make it B, it'll get the same answer. And I'll make 26.2 my B. So A, B, and C. And now that we have our side lengths labeled, how could I plug these into the Pythagorean theorem? Okay, here, let me get a different color here. So A, what's before that? Plus.
R squared.
Yes, A squared plus.
Your 26.2 squared.
A squared plus 26.2 squared. Perfect. So equals 48.5 squared, or C squared. So I have A squared plus 26.2 squared equals 48.5 squared. And whenever we have more complex things that we're going to have to move stuff around, I like to draw that line through my equal sign to keep myself organized. So once we have things plugged in, can we simplify anything before I start moving things around? What can I do?
You take the 26.2 times by itself.
Yeah, so let's take 26.2 times 26.2. Let's square it. So 26.2, I'm going to do the square button. Enter.
686.44.
Good. 686.44. Equals. What else do I need to simplify?
The 48.55.
Yes, 48.5 squared. So 48.5 squared.
You'll get 233,042.5.
Okay, so 2352.25. Okay, so 2352.25. And what else? What am I missing? Yes, my a squared. So let's bring that down. So a squared plus 686.44 equals 2352.25. Now, yes, I need to get everything that is not a on the other side of the equal sign. In this last problem, I didn't have to move anything around because my c was already by itself. But this time, I have to get a by itself. We'll subtract 686.44 to get rid of it and to bring it to the other side. So minus 686.44. And on this side, I know they cancel. Down my equal. And on these calculators, something that helps, I like to just use my arrow keys and hit enter so I don't have to type the numbers out again. So I re-got that. Minus arrow key up.
65.81.
Yes. 1665.81. So 1665.81. And
Bring down your a squared.
good. Bring down a squared. And now we just have one more step to go. Square root it. Let's find the square root of that number. So square root both sides. Get a by itself. And again, if you don't want to type it in all over again, I can go ahead and get my square root on my screen. And then I can arrow key up to that number. Hit enter. And it puts it in there for you. A little faster. Enter again.
40.81.
Yes, 40.81. So A equals 40.81. Very nice. And that's our answer. So that is the only difference between solving for C versus solving for A or B. If you're solving for one of the legs, you'll need to get the other one by itself first. When you're solving for C, it doesn't take that many steps, just one less. So that being said, I'm going to give you guys one to try by yourself. And if we do good on that, we feel good about it, I'll give you your exit ticket, get you out real early today. So I'm going to write over to the side here one that I want you to try on your own. And then I will give you approximately maybe 3 minutes to try to solve that. And then we'll check it together. So try your while you're trying that, I'm going to make copies of the exit ticket so that we've got it. Let's see. So Try on your own. The triangle I'm giving you is like this. Your thing, and let's say 12.3 inches here. Down here, you will have 22.5 inches. So I want you to solve for the missing side. Okay. And I will pause that. I'm going to run copies of what your exit ticket will be, and I will be right back. All right. If you think you know the answer, shout it out.
25.64.
25.64. Did anyone get different numbers?
25.24.
Okay.
18.80.
Okay. 18.84, 25.64, 25 point, what was the other?
24.
24. Okay, so 3 different answers. Did anyone get numbers different than these 3? Okay, so everyone got one of these 3 answers. So what we're gonna do is I'm gonna work this one out on a sticky note, and we're gonna see which answer is correct. So if you're not sure where to start, this is a great place to go. First, I would write down that Pythagorean theorem again. A squared plus b squared equals c squared. So I'm going to write that. A squared. That is not a great color on there. You can't see that very well. A squared plus b squared equals c squared. And now let's decide 12.3 and 22.5. Where should these numbers go in my theorem? B is one of them. Now, which one is always C? The hypotenuse, that longest side, that's the one right across from 90. So we actually don't know C yet. Don't know C yet. So we actually need them to be in A and B. Our legs are A and B. Now, does it matter which one I put where for A and B? It doesn't. You can make it either way. You can do 12.3 squared first, or you could do 2.5 squared first. As long as those two are in A and B, it can be in either order. So I plugged in my A, we'll call that A, call 22.5B equals, now I don't know C squared. So we're going to be solving for C here. One. So at this step, I've got my numbers plugged in. Now, if you didn't plug your numbers in this way, and you're seeing this, and you're still not sure why I put it in this way, please let me know. Because we can absolutely talk about it more. Give me like look at me and like blink your eyes a bunch if you have no idea what's happening. Okay, good. Everybody's doing good. Good. Okay, so what do I do now? I've got it plugged in.
Find out what their square equals. So
Yeah.
12.3 squared equals 51.
Okay, 12.3 squared is, you said 100.
51.
Okay. Good. 151.29.
2.5 is 506.25.
Okay. 506.25. Is anyone getting different numbers when you square these? Or are we getting the same? Okay, cool. So now we just bring everything down, equals c squared. And now what? Add them together. What do we get when we add these numbers together?
657.
Mm-hmm. Good. 657.54 equals c squared. And there's just one more step. What do we do now? Yes, square root it. So I am going to type into my calculator second square root symbol 657, include every decimal, 0.54. Enter. I got 25.64254,278, and so on. We're just going to put 25.64. That is our answer. Equals C. Okay, so if you did not get 25.64, do we understand maybe the mistake that we made previously?
Yes.
Okay, perfect. I love it. So we got that. The 0.24, whoever got that, do you know what went wrong? Okay, just a couple off. Perfect. So 25.64 is our answer for C. And that is going to be it today. Now, guys, on your exit ticket, you're going to be doing a very similar problem, but you will answer one more question about the triangle. And that triangle question will be to classify the triangle. Is it acute? Is it right? Is it obtuse? And then is it scalene, isosceles, or equilateral? So that last note page is going to be very helpful. So on this one, for example, do I have all sides the same length? No. Do I have two sides the same length? No. So what kind of triangle would this be?
Or no, scaling.
Scalene.
Sorry.
Good. So this, you're
I got
okay.
mixed up.
You're okay. Scalene is the type of triangle. This is three sides that are different. And then based off of angles, what type of triangle is this? On the title of your page. It's a right triangle. That's a free point for you. Because, of course, if you're using the Pythagorean theorem, you're going to be having a right triangle. Yes. So perfect. Perfect. Okay. Guys, that's it for your notes today. I'm going to go ahead and zoom out on that. And your exit ticket is already printed off and up on that front table. And this is what it looks like. Day 10 exit ticket. This is due on Friday. You have a triangle that looks like this. First, you're going to say, is this an acute, a right, or an obtuse triangle? Is it scalene, isosceles, or equilateral? Then, you're going to use the Pythagorean theorem, and you're going to solve for the missing side length.
You have to times it by itself.
And that is all. I'll leave this up. And
Is that what
once you
happened?
have finished that exit
Is that
ticket,
what
you
you
are
swear?
free to go.
You put it in.
The end.